another rero video. Today we're gonna talk about wire connection.
Now here's the controller. As you can see on the sides, there are 1, 2, 3, 4, 5, 6 female ports. These ports are used to connect the controller to the motors, but there are only 6 ports, but it does not mean that the controller can only control up to 6 motors or sensors at one time. Why is that so? It's because the rero controller actually uses a wiring scheme called a daisy chain to connect with the motors and sensors. What does a daisy chain mean? Now this is a daisy chain. The term daisy chain in electrical engineering practically means to connect devices in sequence. So let's say I connect this male port to this female port on the controller. With this, the controller will be able to control 4 motors and 1 sensor with only 1 port. Now with this setup, it can control a lot of motors, and it does not matter if you connect it to the different ports as long as the motor or sensor is connected to the controller through any wires, that it will be able to communicate with the controller. So the advised limit for 1 port is 10. This is to avoid too large a current flowing through the wires that would cause damage. So if you open your quick start guide and skip to step 2, you will see this diagram. On page 8, you see this diagram. So these 4 diagrams are actually demonstrating how the servos are connected to the controller. So let's look at diagram 1. You can see that all 8 servos are daisy chained together and they're connected into 1 port. Now this can be done because since all the servos are connected to the controller via daisy chain, then all these servos will be able to communicate with the controller. In this second diagram, you can see that there are 4 each connected to 2 controllers, 2 ports of the controller. So this also works because the daisy chain is valid. Now here we have something a bit more complex, but actually it's still the same thing. So here we have 1 servo connected to 1 port. This is another single servo connected to another port, and then here's a couple connected to this port, and so on. So as long as any of them is connected to the controller, it's okay. But here we can see some errors. These 3 are okay. As you can see here, this servo is connected to the cell. Since it's not connected to the controller, it will not work. The same for these 2, for these 2 sets. So this one is connected only in the loop to each other. Since it's not connected to the controller, it will not work. And this one is open-ended too. So it's not connected to the controller, it will also not work. So when you're building a robot, it's easy to get confused because the motors are scattered everywhere. Let's say on the arms of the robot, the legs of the robot. So keep in mind that the servos have to be connected to the controller in order to work. So here's an example. Let's say I built a robot that's a structure like this. So I'll connect all the wires together. Just connect, and then hey, I suddenly realized that I left the last connector as a female connector. So the output port on the controller is a female connector, so I can't connect the female to the female. So how do I fix this problem? Of course you can disconnect everything and reconnect it, but one of the ways to fix this is by using a male-male extension. Because I connect the male to the female first, then it will leave me with the male in the end, so I can put it into the controller. Now this will work because the concept of daisy chaining is as long as the devices are chained in sequence and then connected to the controller, then everything will work. So what if I just change the connection? Then I don't need to use this extension. So I just change it. Connect this male to the female. Then I'll just use this male to connect it here. Then you realize, hey, this isn't long enough. So there's also a male-female extension. So there are different types of extensions to help you solve different types of problems you meet. So you can just think around and then finally you can see that everything is connected. So you also have to remember that there's more than one way to connect the wires. It's just to your liking or based on the situation. What you think is the best way to solve the wiring problems you have, and you can just use it. Okay. Now here comes another problem. The wires are sticking out everywhere. You can see that it's very untidy, and in some circumstances the protruding wires may cause malfunction in your robot. Let's say it will tangle up with the moving parts and everything. So to solve this, we have the wire clip. You can see it looks somewhat like a connector on this side, but here the other side you can't connect anything to it. So I just slide it in. So it has two uses, but it serves one purpose, that is to make your robot more tidy. Let's say, I think I'll connect it to the back. Connect it here. You can see this part here. It's actually used to hold the connectors of the wires. So like this. You can see it won't move around. So with this, the wires won't protrude everywhere. Also, you can use it like so. See, this wire, it isn't connected anywhere. So you can use it. Use the sides. Use the sides like this to hold the wire. Clip onto the wires like so. So this way, the wires won't protrude anywhere, and it will make your robot more tidy. And in some circumstances, it will solve some technical problems your robot might face. Let's say the wires are tangled with your parts. So, and most importantly, it's important to plan ahead so that you won't design a robot in a way where the wires won't be able to connect to each other. Now that your servos are connected, there's one way to check if they're connected. Is by turning on your controller. You can see the red lights and the ledges. So if there's a red light, it means that the servo is connected.